Hi everybody, this is Mrs. Lehman from Math with Mrs. Lehman. I'm here today with my 4th period class. Hello! So we have a bell ringer today that brings in a few different skills. So, you know, it talks about rates, it talks about two-part expressions. So this has to do with one of my favorite places on earth, Disney World. So it says, at Disney World you can rent a minivan to take you to other parks or resorts like a taxi. There is a fee of $15 per trip plus $3 per mile. How much would it cost to travel by minivan from Magic Kingdom to Animal Kingdom that are 6 miles apart? So there's these are two of the different parks at Disney World. They're 6 miles apart. If you want to hop in that taxi service by Disney, we want to figure out what the price is. Okay, so what would our first step be? Yes?
6 by 3.
Why would you multiply 6 by 3, Star?
Because it's 6 miles and $3 per mile.
Perfect.
So that would show you how much money it is to travel.
Very good. So the traveling part of it is going to cost you how much money? $18. Very good. So she said you're going to take 6 times 3. That's going to give you 18, right? What else do we have to pay? It's not just going to be $18. Troy?
What's the fee?
Plus the fee of $15. So we're going to take 18 plus 15, and what's our total? 33. Very good. So $33 is your answer. Raise your hand if you had $33. Woohoo! Nice job, guys. So another thing I want you to write down is how we would write this as an expression. So that does not want to erase today. So there are different places you could travel in a minivan. You could be going to Epcot. You could be going to Hollywood Studios. And these distances are going to be slightly different depending, you know, if you're going from different resorts, etc. So how could we write an expression that we could apply to any trip we take in a minivan? Does anyone know? We know we're going to always have to pay the what? The $15 fee. So we could say, okay, we're always paying the $15. Plus, what else are we going to have to pay? Chris? $3 per mile. Now, the number of miles could vary or change, right? Depending on where we're going. So we could just use a variable for that. So how would I write that with a variable? Plus what?
3 times m.
Very good. So we could simplify that to just 3m. Nice job, Jackson. So 15 plus 3m. And we could figure out how much this trip would cost us regardless of where we're going. Any questions on that? And if you wonder why your parents may not be taking you to Disney World, I think this example can show you it's ridiculously expensive. All right, especially when you got multiple people to take. All right, today what we're going to do is go over your homework, which was writing addition expressions and subtraction expressions, and then we're going to do some cleaning up of some expressions that have some extra nonsense in there we don't need. Then we're going to move on to factoring expressions using the greatest common factor, okay? So we'll talk about that more when we get there. Right now I need you to turn to page 36. If you were absent, you can put your pencil down, pay attention to what we're doing, but then you'll be in charge of turning that in yourself, but just don't copy down the answers right now, okay? All right, so the first question says, write 2 expressions to show a number decreased by 11. So I'm actually going to have you write one expression to show a number, and I don't really care about drawing these models, okay? So do they tell us what number to use? No, so it could vary, right? So instead of picking a number, it could be any number. So we're going to use a variable. So what did you guys use for a variable?
Y.
You used y. Okay, that y works. A, B, C, D, we have options, okay? So let's say it's y. We're decreasing y by 11, right? So what operation does that mean? Alex? Subtraction, very good. So it should be whatever variable you picked minus 11. Now, kids in the other classes misinterpreted this as pick a number, right? And they picked a number or plugged it in. right? It's not asking you to pick a number and plug it in. It's asking you to write an expression for a number that they didn't tell us the value of, okay? So if you don't have that, fix it. And you need to write minus 11, not y equals 11. All right, the next one, write an expression to show the sum of x and y. The word sum tells us to do what, Jose?
Add.
So our expression would be?
Addition.
Yep.
X plus y.
Very good, x plus y. Who here had x plus y? Woohoo! Well, you were absent, so write an expression to show h decreased by 13. Decreased by means what operation to Phelan? Subtraction, very good. Is decreased by a flip-flop phrase? No, it's not. What is our flip-flop phrase? Less than, very good, Bryson. So in this case, it's not a flip-flop phrase, so you're going to just have h minus 13, right in that order. Okay, who here had h minus 13? Nice job. Write an expression to show k less than 3 5/10. We're at the pool of algebra. You might stumble across some flip-flops. All right, so this is a flip-flop phrase, meaning we got to switch the order of subtraction of how they're listed, okay? So we have k less than 3 5/10. So what would come first, the k or the 3 5/10? Cassie? Beautiful. 3 5/10 minus k. Any questions? And again, your clue word here was less than, being the time to switch the order of how they're listed. Write an expression to show the sum of g and h reduced by 11. So we have two operations going on, but the first thing we need to do is do what, Colby? Beautiful. G plus h. And then we're going to reduce it by 11, so we're going to subtract 11 there. Now, the parentheses in this case, are they technically necessary? No, because order of operations would stipulate that we would go, you know, addition, subtraction in the same category, but we come to addition first, right, in this problem. So that would have ended up being first anyway. So if you didn't have the parentheses, it would still technically be fine, but personally, I think it's a little more clear. You want to definitely find that sum first, then subtract 11 from it. Write an expression to show 5 less than y, then they have a comma, plus g. So we need to write 5 less than y first. What's 5 less than y? Connor?
5 less than y is y minus 5.
Very good. And then plus g, so we are just going to write plus g. All right, so again, parentheses in this case technically wouldn't matter, because even if we took those out, we'd still have to do this part first because it came first in the problem, okay, in that category. Any questions so far? All right, and then the last one here says write an expression to show 5 less than the sum of y and g. Oh, we got a flip-flop phrase, and we have two operations. So what are we doing here, Cassie? Very good, nice job. What about parentheses? Are they technically necessary in this case? Nope, because we would be adding y plus g anyway first. All right, any questions? Bryson? Yes. Yep. I think it helps clarify that that definitely needs to happen first, but, you know, order of operations would tell you to do that first anyway. So let's go to the next page, page 37 for you guys. I'm sure some of you guys watching this and some of you guys in here, I kind of jokingly say that we're going to Marie Kondo this. Has anyone watched that show on Netflix with Marie Kondo? She's going into people's houses and helps them tidy things up, and they go, she's from Japan, and she's an expert at decluttering, and so she's come up, she has this method where you're supposed to take everything in categories and like hold the items and like, oh, does this spark joy? And if it doesn't spark joy, you get rid of the stuff that doesn't make you happy, essentially. So lots of jokes on the internet about that, like, oh, so far I've gotten rid of my treadmill. Jacob?
Super Nanny, but with cleaning houses.
Yep. So it's all about efficiency, really. Like you have what you need. You don't have any extra. So it's kind of a minimalism type concept. Yes.
What if you have the ashes of someone, and that makes you sad?
I guess it's all a personal journey, Jackson. I don't know what to tell you. So anyway, we're going to clean this up. We're going to be really minimalistic about how we write these things. So as you advance through different algebra classes, you'll notice we don't use the X anymore for multiplication. We use either a dot, or in algebra, we just use coefficients, right? So instead of writing 6 times B out like this, how would we write that? Hunter? 6B, very good. All right, and we have 4 times 3 times H. How could we clean that up? Alex?
Multiplying the 4 times 3, making it 12H.
Very good, 12H. We don't need any dots here because when you have a number and a variable next to each other, the number always goes in front, by the way, when you have a coefficient. That means multiplication. All right, this next one, 2 times 2 times 2 times A times B. Do not tell me 6 something. DeQuaylen.
2 times 2 times 2 equals 8, and 8 times AB.
Very good. So now we have 8. Well, hold on. What was I going to ask? 8AB. Do we need any dots in there?
No.
No, we don't. We're going to be very minimalistic here. We know that when we have numbers next to variables, that means multiplication, and variables next to variables, that means multiplication as well. No multiplication symbol is needed. All right, so this one has a lot of kids' trick. Does anyone have 5M, 3P on their paper? All right, you can go more simple than that because those are all being multiplied. What could we do with the 5 and the 3? Cassie? We can multiply those. So 5 times 3 is 15. So 15, and then what do we have for variables being multiplied, Connor?
MP.
Very good. So your best answer is 15 MP. Who had 15 MP? Very good. Who had 5M 3P? All right. So I'm glad they had that example so you won't do that again. All right. So you can keep multiplying there. All right. 1 times G times W. How could we write that, Chris?
1.
What if I told you you could simplify that even more? Cassie wants to help you. Cassie, what can Chris get rid of in that?
1.
The 1, yeah. It's kind of redundant to say 1 times G times W because any number times 1 is itself, right? So we can kind of cut out 1s as coefficients. We don't need a coefficient of 1. Any questions on that? Who here did pretty well?
Yeah, I got none of them because I was absent.
You were absent. Yeah, great. Okay, we're going to skip a few pages. We're going to skip around this lesson too. So we're going to talk about factoring expressions. So we're going to take our little mental time machine here and go back to talking about factors. Who can remind me what a factor is? Jackson.
Part of a whole number.
Okay, so can you be more specific?
No.
Can someone help him out? A number can be broken into its factors, right? How? How do we break a number into its factors? By division, right? So a factor is a number that can be multiplied by another number to get a product, right? So you can take a number and divide it by its factors. Okay, so when we say like 6 is divisible by 3, 3 is a factor of 6, and 2 is another factor of 6, right? So numbers that are multiplied to get a product. So we're going to work on breaking algebraic expressions into its factors, all right? So this takes a little bit of thought, but it's not terribly difficult. So we're going to just look at a visual first. We have 5, 5, 3, and 3. How many 5s are in that model?
2.
Everyone?
2.
2, yep. How many 3's are in this model? 2. What does the expression represent in words? If I said, what does this show us, what would you say? Some other people in here need to participate a little bit more. I can't call on Cassie for everything. How would I say that? If I said, describe that model to me. Don't tell me, oh, it's a bunch of rectangles. what could you tell me? Jacob.
It's trying to show that the entire bar is not entirely equal to 5s, and it's also got 3's inside.
Very good. How many 5's do we have?
2.
So could we say we have 2 groups of 5?
Yeah.
And?
2 groups of 3.
There you go. All right, that's what we're going to write down. So, 2 groups of 5 and 2 groups of 3. What expression could we use to represent the model? So we talked about this before when we talked about how many groups of another number. What operation is that? Troy? Multiplication, very good. So we would say 2 groups of 5 are 2 times 5 plus what? Very good, plus 2 times 3. And that's kind of shown right up here, right? We have this group plus we have this group over here. All right, so in this case, they switched around the blocks a little bit, and they said, okay, what if we rearranged it so we have 5 and 3 together, and then another 5 and 3 together? So again, how many 5's are in this model? 2. How many 3's? 2. What does this expression represent in words? We have how many groups of what? 2 groups of, very good, of 5 plus 3. Do we have the same quantity in both models? We do, right? We have 2 5's and we have 2 3's in both, right? So, how could we write this one out? We have groups of 5 plus 3 and we have 2 of them. Yes.
5 plus 3 in parentheses times 2.
Very good. Nice job. 5 plus 3 in parentheses, and then we're going to multiply that by 2. Now, again, in algebra, we probably wouldn't write times 2 at the back end here. We would put the 2 in front of that quantity, and that means 2 times everything in there. We have 2 groups of 5, plus we have 2 groups of 3 as well. Okay? So, we're going to skip now to, skip now to example 3 somewhere. Maybe? Just don't mind me as I flip around here. Okay, so example 3, we're going to use the greatest common factor. So we're going to look at the terms of the expression, and we're going to look at the numbers, we're going to look at the variables, and we're going to pull out the greatest common factor for both. So we've got to make sure we can divide that number into both terms, okay? So, or multiply that to get both terms. So 3f plus 3g. What do you think the greatest common factor of these two terms are? Logan? 3. Very good. So we're going to pull the 3 out in front. We're going to kind of reverse the distributive property here. So 3 times what will give us 3f? Pretty easy. You're going to kick yourself when you get this one. Logan again?
1.
3 times 1 would give you 3, but we need f2, which is 1f, and we don't need to write the coefficient of 1, so we're just going to say f. All right, so 3 times the quantity f, and then you're going to put the operation symbol in here. So that's addition. 3 times what would give us 3g? Just g. Very good. So when you distribute this out, you'd say 3f plus 3g. Make sense? We're going to practice it a few times, so if you don't get it right away, it's not a big deal. All right, what What is the GCF of this problem? What number can we pull out in front? Troy? 3, very good. Let's see. Let's go on to the next example. Or next part of example 3. Kind of confusing. 6x plus 9y. So we're looking for the biggest number we can use to multiply to get 6, and we could also use it to get 9. What do you guys think? 3, very good. So 3 is a common factor to both. We're going to pull that out in front. Do x and y share any factors? No, they don't. So just 1, and everything shares 1, right, as a factor. So that's not going to do us a lot of good. But sometimes it's the numbers that share factors, sometimes it's the variables that share factors, and sometimes it's both, okay? So 3 times, and sometimes they don't share any factors and can't do anything with it, but in this case, 3 times what will give us 6? 2. So we also need to have it be 6x, so we need to throw the x in as well. Then you're going to put the plus sign. 3 times what will give us 9y? So what's the second term inside here, Connor? 3y, very good. All right, what is the greatest common factor of this problem? What's the GCF here, Colby? What number did we pull out in front? You mean 3, yes. 3, good job. All right, let's go to the next one. We're going to just try to get through as many examples as we can so you can get comfortable with this. All right, so in this case, they have 3c plus 11c. Do 3 and 11 share any factors? No, they're both what type of number? What? Somebody said that, I think. Cassie? They are both odd, but they are also prime. Very good. So that means they just have factors of 1 in themselves, so they don't share any factors. What about c and c? Do they share a factor?
Yeah.
What? C. So we're going to pull the c out in front in this case. The smartboard is writing kind of weird. All right. C times what will give us 3c? 3. So we're going to put 3 and then plus. Do I need to write another c on the inside here? No, because that would give us 3c squared if we did that, because it would be a c times a c. We don't want that. C times what will give us 11c? Hunter? We're on question 3. And we just said that to get 3c, we multiply c times 3. So to get 11c, we multiply c times what, though? 3c plus this part. We're looking for how do we get 11c. We have c times what will give us 11c? 11, yep. Make sense?
Yeah.
Yeah, it's like kind of ridiculously easy, really, and sometimes that makes it a little confusing. It's like, oh, it's right there. Okay, so the greatest common factor in this case wasn't a number, it was the variable that we don't know what it's worth, c, okay? That was our GCF. All right, the next one. We have 24b plus 8. 24b plus 8. So we're looking for a common factor of both terms, a number that we can divide both 24 and 8 by. We're looking for the biggest one. The biggest one. DeQuillen? Alex kind of budged in front of you there. 8, yep. All right, so 8 is the greatest common factor. I guess the good news is you're all so excited to answer, you know what I mean? But please just remember to raise your hand, okay? 8 times what? Bless you. 8 times what is 24b? Kyla? 3. What? Nice job. 3b. Plus 8 times what will give us 8? 1. Yep, so we're going to say 3b plus 1. Making sense? All right, what's the GCF here? 8, yep. All right, nice job. Let's practice some more on this next page. I'm going to let you guys try a few on your own in the next 5-6 minutes. So I'm going to pause this while you guys work on some things, and I'll check them as you go, okay? So we'll be right back. I was going to say it, but I avoided it. We'll be right back after these messages. Okay, so a lot of kids are done with part A and B. So the first one, you should have pulled out 7 and then 7x plus y here. 7 times the quantity x plus y, I should say. When you distribute that out, you'd be multiplying 7 times x to give you 7x, and then adding 7 times y, which is 7y. Okay? The next one, 15g plus 20h. What's the GCF there? Everyone? 5. Yep, that was not everyone. So 5 times what gives us 15? 3. But we also need to multiply by the variable g, right? So it'd be 3g. Because if we had 5 groups of 3g, that would add up to 15 g's. Plus 5 times what gives us 20? 4. And then we got to multiply also by h, all right? Who here had 7 times the quantity x plus y for A? Right? Who had 5 times the quantity 3g plus 4h for B? All right, nice job. Go ahead and move on to question C, which is a little more challenging as we get to bigger numbers, okay? So go ahead. Anyway, so what's the GCF of 18 and 42? Star? 6, very good. So we're going to pull 6 out in front, and m and n do not share any common variables, or I'm sorry, factors. So 6 times 3 gives us 18. We need m attached as well, plus, and then 6 times what gives us 42? 7n. All right, so your homework tonight is exactly like this. It's page 48, question number 2, which has questions A, B, C, and D. I will be taking an accuracy grade on that, so please make sure you're really careful to find the GCF. You are expected to use the GCF, not just any common factor, okay? So you have 4 questions for homework. Any questions for me? Colby? Yes. All right, thanks for watching Math with Mrs. Lehman. Please don't forget to like and subscribe.